Hello my dear children, once again welcome to our physics class. Hope you all are fine over there. So we were discussing our chapter 8 motion. We were doing a revision session. So we stopped with the velocity and speed. Today we are going to continue the revision of the same chapter, motion. So let's get started. So after speed and velocity, another physical quantity that we discussed in this lesson is acceleration. What do you mean by acceleration? It is a measure of change in velocity of an object per unit time. So wherever there is a change in velocity, there will be an acceleration. Change means change can be an increase in velocity or change can be a decrease in velocity. So whenever the velocity increases or whenever the velocity decreases, there will be some acceleration. Okay, so what is acceleration? It is the measure of change in velocity of an object per unit time. So acceleration can be caused either by change in direction of motion or change in speed or both. Children, acceleration is a vector quantity. Okay, so if there is a change in speed or if there is a change in direction, there will be acceleration. I told you whenever there is a change in velocity, there will be an acceleration. So change in velocity can be change in the magnitude of velocity or change in the direction of that object. Okay, for example, consider an object is moving with a velocity of 5 meter per second towards east. Okay, consider an object A which is moving with a velocity of 5 meter per second towards east. Okay, now consider the same object A. It is moving with the same velocity 5 meter per second towards west. So will there be any acceleration now? Yes, because initially the object was traveling with a velocity of 5 meter per second towards east, but finally the object is traveling with a velocity of 5 meter per second towards west. So even though the magnitude of velocity is same, the direction of motion is different. Initially object A was traveling towards east, but now it is traveling towards west. So even if there is a change in direction, there will be acceleration. It is not necessary that the magnitude only must change for an acceleration to occur. Okay, so that is meant by this statement. Acceleration can be caused either by the change in direction of motion or change in speed or both. And SI unit of acceleration is meter per second square. What is the equation to find out acceleration? Equation to find out acceleration is change in velocity by time taken. Okay, so equation to find out acceleration is change in velocity by time and the unit is meter per second square. So I told you it is a vector quantity and acceleration is taken to be positive if it is in the direction of velocity and negative when it is opposite to the direction of velocity. You know that acceleration means change in velocity. So if acceleration or if acceleration is in the direction of velocity, then it is taken as positive. But if acceleration is opposite to the direction of velocity, it is taken as negative. For example, whenever you apply brakes on a car, the velocity is in the forward direction, but acceleration is in the backward direction, isn't it? Whenever you apply brakes on the car, the velocity of the car decreases and finally the car will stop. So here velocity is decreasing. So acceleration will be negative, and that acceleration is also known as deceleration or retardation. Okay, so negative acceleration is also known as deceleration or retardation. So whenever the velocity decreases with respect to time, we can experience a negative acceleration or deceleration or retardation. Now, On the other hand, when you are increasing the speed of the car, acceleration is positive because velocity and acceleration both are in the forward direction. We had already studied one expression for acceleration. It was change in velocity by time. So this expression can also be regarded as the equation to find out acceleration, that is v minus u by t, where v is the final velocity, u is the initial velocity, and v minus u means final velocity minus initial velocity, that is change in velocity. So acceleration A is equal to change in velocity by time t. So if v, u and time is given, we can easily find out acceleration. Now, most important concept of this chapter is graphical representation of motion. So we had studied about different types of motion, that is uniform motion, non-uniform motion, uniformly accelerated motion, non-uniformly accelerated motion, etc. So what do you mean by uniformly accelerated motion? If the velocity of an object increases equally in equal intervals of time, okay, it is regarded as uniformly accelerated motion. So whenever the velocity of an object changes equally in equal intervals of time, it can be regarded as uniform acceleration. On the other hand, if the velocity of an object changes unequally in equal intervals of time, it can be regarded as non-uniformly accelerated motion. Okay, so what is the importance of graphical representation of motion? So we can interpret the data quickly whenever you represent anything in the form of graph. So that is a peculiarity of the graph. So it's very important to study the graphical representation of different types of motion. The first graph of this chapter is distance time graph. So in the distance time graph, distance is taken along the y-axis and time is taken along the x-axis. So this is the distance time graph. See, distance is plotted along y-axis. Time is plotted along x-axis. And the first graph shows the distance time graph for uniform motion or for uniform speed. See, graph is a straight line starting from origin, and graph is a straight line with a slope. So from the graph it is very clear, as time goes on, the object covers more and more distance. And the second graph represents the distance time graph for non-uniform motion. It is a curved graph. So here it is very clear, the velocity of the object, the object covers unequal distances in equal intervals of time. So in the first graph, it is very clear, the object covers equal distances in equal intervals of time. But in the second graph, it is very clear, the object covers unequal distances in equal intervals of time. Next, from the distance time graph of uniform motion, we can find out the quantity speed. And how is it possible? Slope of the distance time graph gives us speed. So how will you find out slope? So you can choose any 2 points on the graph, and from those 2 points you can draw 2 normals to the distance axis and 2 normal to the time axis. That means from the any 2 points chosen on the graph, draw 2 normals. So this is the first normal or straight line to the y-axis, and draw another normal from the point to the y-axis. Similarly, draw 2 normals to the x-axis from the same 2 points that you have chosen on the graph. Now, slope of this graph, the equation to find out slope of this graph is S2 minus S1 divided by T2 minus T1. And the slope of the graph gives you speed. Okay, so the slope of distance time graph gives you speed. So which physical quantity is obtained from the distance time graph? That is, slope of the distance time graph gives you speed. Okay, So that's all about the distance time graph, and we will discuss another graphs in the next session. So with this I am concluding my topic. Please go through these topics and revise it very well. Attend the test and post me the answers. We will meet in the next session. Till then, take care. Stay home, stay safe. Keep learning.